Dear students, now as already we had seen various practicals in virtual lab based on the DC motor, how the field resistance control method is used for the speed control of DC motor, then armature resistance control, as well as some ward lever node method that we had seen for the DC motor. Now we are moving towards the transformer equivalent circuit where we will determine it from the open circuit as well as short circuit test. So that means OCSC test. So here we can say determination of transformer equivalent circuit from OC and SC test. So let us see the theoretical part in that. So here we can understand why these open circuit and short circuit tests are performed. So basically the whatever parameter of the transformer, for example like efficiency, voltage regulation, circuit constants. So whenever we need to determine that parameter, we have to perform open circuit and short circuit test. So this test mostly performed without the actual loading. Why? Because it required very less power for the testing. So we can say that OC and SC will give us a very accurate result as compared to the full loading test. Fine. So let us understand open circuit test. So in open circuit test, you can see here in the figure, okay. So that figure is showing supply is given, ammeter is connected, sorry, voltmeter, ammeter are connected here, and whatever be the whatever be a open circuit secondary points are there that kept open. So here we can write that are open, right? So uh, according to that, it is known as a open circuit test. So wattmeter, ammeter, voltage that are connected to the primary side, and whatever be the nominal rated voltage that has to be supplied for the primary with the help of AC supply source. So secondary winding here, as we see, it's kept as a open, and voltmeter is connected to the term. So that voltmeter will measure the induced voltage, and as we know that the transformer secondary winding kept as open, so no, it means it is not having any load, so there may not flow of flow any kind of current, right? So whatever be the value of no load current, that will be very small as compared to the full rated current. Okay, so let us see which parameters we are going to calculate. So here we know that the W0 is wattmeter reading, V1 that is again voltmeter reading, I0 is the ammeter reading. Then the iron loss of the transformer, we can say that Pi is equal to W0. So whatever be the wattmeter is showing reading, that will be your iron losses, and that W0 can we can calculate with the help of V1 I naught cos phi. So again cos phi we can calculate, that is with the help of this equation, cos phi is equal to W naught by V1 I naught. So from that again there we can find out the working component. Okay, so just keep in mind, right? So whatever be the working component is there, that we can find out by the help of equation number 2, and the magnetizing component and all the things. Then for the short circuit test, the simple change is here. You can see in the short circuit the difference is only where the primary was open, secondary was open in case of the open circuit test, but here that primary is short circuited. Here you can see it is a short circuited, so means we can say the terminals are short circuited. So whatever be the low voltage source that is connected across the secondary winding, because very full load current will goes to flows through these both primary as well as secondary winding. So that full load current will be measured with the help of ammeter, and the low voltage source that will be applied across the secondary winding. So that is around 5 to 10% of its normal rated voltage. Okay, so that is all about the theoretical overview of OC test, SC test. Here again what parameters we are finding, that is again wattmeter, which is showing us copper losses, the short circuit voltage, it will be shown by the voltmeter, all the things we will see on the screen. Okay, so pre-test you go with your own. So now I'll click on simulation in next window. Okay, so make the proper connection by clicking node as instructed below. If the wire is misplaced, click the node to detach click the node number to detach the node wire. Okay, fine. So here first, now we have to make connections like that way. So first of all, we need to give this supply to this one. Okay, from this we need to take here, and from this we need to take here. So that is the supply. After that, this negative will goes to the voltmeter. So let's take it to the voltmeter here. Then we can see this side, it is given positive is given to voltmeter this side and ammeter this side. Okay, so let us take here, and another was at negative side. Okay, so let us take this one. Okay, then here these positive and M, those are shorted, so we can say voltage, this is a shorted. Then this C and L is again shorted, so we can short this one also. Just a second, there may be a some, yeah. So this is a shorted here, this is shorted here. Okay, and this P1 is given to L, so let us give it, P1 is given to L, and this V is given to this P2. This V is given to this P2. Okay, then this ES2 is given to the positive, that will be here, and we can connect this here. So might be that is a proper connections. Okay, so let us have a look on check connections, and you can see please complete connection. Okay, so somewhere I missed a wire. Okay, so this voltmeter we had connected across the open circuit. Okay, we had connected across its open circuit, so it is okay. For primary side, my supply is coming. Okay, so somewhere there is one missing place, and that is not like that way. Okay, sorry, I'll just connect that one, and this should be here. And now check connection, that is saying it is a correct connection. Okay, so now what we will do, we will just on the MCB, and after see click on button connection is not, click auto transformer to change all meter, click add to table. So we'll take, now see, we'll take the connections here. So see, I'll click on this, so it started. Click on auto transformer, so auto transformer is set, and now I'll click on the add table. So now table is added. So this is my reading, this is my reading, no need to take multiple readings. Okay, so only single reading, it is enough. Okay, so with this we'll go for the short circuit test. Okay, so these are the readings, right? So now after this, then see here, click add table button, reading of the open circuit transformer. Then we have done open circuit transformer, then click the short button for the short circuit test. See, here is a short circuit button, I'll clicking on that. So this is again here opening. So now we'll do the connection for this, same, it will positive negative. Okay, then we have to make connections like that. So from first there is one here and one is P2. Okay, so it will be here, and again it is coming to the P2. Then from these positive and this positive. Okay, so this positive I'll take here, and one more at this place. Okay, then we will short a CL. So here I'll take MC, that will be here. Okay, and now V2 P1, that will be connection. L to P1, V2 P2, that L to P1 and V2 this one, and we will short these two, right? So this is the connection. You can click on check connection, and these are the correct connections. And here we will click, okay, all the connections are okay. So now we will click on the MCB, and again we'll start the auto transformer, and we will take the reading, add to table. Okay, and that will click on submit. So once I'll click on submit, then my transformer equivalent circuit diagram will get ready. It will get ready. So I click on the print, and that will be stored here. So how it will be looks like? So that print will be like this way. See how we have done This will be my open circuit test, that is the table. This is short circuit test, these are the table, and this will be my equivalent circuit. Okay, so means it works like that, so simple. Okay, so that is how you have to perform. So see what is difference. Only everything we had done same, but here only in first that we had kept this open, and here we kept it as a close. So that is the difference. Okay, and every stage in this virtual lab it is showing us, okay, what to do and what to do not to do. Okay, so with this again, if anybody have any doubt, you can ask. Okay, so here you can go for the post test also. Okay, so while estimating voltage regulation transformer, keeping which will be constant, and just solve this small numericals. Okay, so this is all about the determination of transformers equivalent circuit from open circuit and short circuit test. Okay, thank you very much.